Hey there, so for today's video, I'm going to show you how to make our open source cation exchange membrane. They're incredibly cheap, very chemical resistant, and comparable to other commercially available ion exchange membranes. So this is going to be a step-by-step video showing you exactly how to do the whole process. What you're going to need, well, for tools, you're going to need this high-speed grinder. There's many different types on Amazon. This is the specific one I purchased. I highly recommend getting this one. I've used numerous, over almost 2 dozen different blenders. This is the best one that works. Please just get this one and you'll have great results. Next thing is, of course, you need the cation exchange resin. I'll show you exactly which one on screen, which one I purchased on Amazon, but any cation exchange resin will typically work that are used for water softener. Furthermore, you can actually change which resin you can use for different selective properties and so forth, but I'll make a specific video for making anion exchange membranes as they require a couple extra steps. I also want to make it clear that you do not want to dry these resins out. You do not want to have them dried out. I have them in this clear container, which is incredibly heavy, but as you see in the bottom, I have water. And the reason why is because it allows the humidity to stay and keep the resin moist. Again, do not dry them out. I hope I'm making this clear. Do not want to dry out the resins. You do not want to dry out the powder. If you crush them, do not dry it out. Keep it in a wet container. You do not want them to be too wet. Just keep a couple inches at the bottom, and that will allow the top to drain out and be at the perfect humidity, the perfect moisture level to be properly pulverized into a powder. Furthermore, after you pulverize it into a powder, keep it in a sealed container. You do not want to let it air dry. You do not want to dry it out before you mix it in. You want to keep it moist. Okay, so next, after that, you'll need a clear PVC cement. So this is my favorite brand that I use. I'm not affiliated with them in any way, but you can get this at the hardware store. Don't use gray PVC cement. Don't use something else. Just stick with this clear PVC cement. Doesn't have to be this exact brand, but clear PVC cement. Okay, don't you can try. I'm not saying it doesn't work, but keep it simple. Make your first membranes just using clear PVC cement. Next, I highly recommend getting some fiberglass. So I really recommend this fiberglass strands, cut strands. They work very well when you combine them and make it into this composite fiberglass structure that is very strong. And also, although I did dry this out, you do not want to dry your membranes. This is just for demonstration purposes so you can see what they look like, but you do not want to dry out the membranes, you do not want to dry out the resin, you do not want to dry out the powder. And then you want some way to mix it all together. I highly recommend disposable cups and a disposable spoon. That way you can simply throw it away when it's done, as PVC cement is kind of not fun to work with and clean up. And then finally, you want a substrate material to actually apply it on. This is some polypropylene sheathing that you can purchase at your local hardware store. This is very important as it allows you to place the membrane on top, allow it to dry out, not fully. You don't want to fully dry out, just so let it apply, and then it allows you to simply peel it right off. Alrighty, now we got our blender out. One thing to note is you don't want to leave the resin in your blender because it will rust it up, as you see here. So be cautious with that. But we'll open up our container of resin and put them in here. Now, don't get completely scared if you do dry this out, the resin completely. It's just really difficult to work with it afterwards. It becomes very hard. So I recommend just let it. Don't dry it out, right? But also don't be scared if you do dry it out. You just put in a container like this with some water and let it sit for a couple days, or even let it soak and then drain it out, because you don't want it too wet, otherwise it'll stick to the surfaces and it won't properly mill. But as I said earlier, this is the best texture. Additionally, you don't want to overfill this. I wouldn't do more than a third. This is probably closer to a sixth of the volume, but don't overfill this. Less is better, so be careful with that also. Additionally, I recommend doing this outside. I'm doing it inside just for demonstration purposes. Wear gloves, wear PPE, wear ventilation. Again, I'm doing a video, right? So I'm doing demonstration, but do this outside. Do it where it's well ventilated, especially when you start working with the solvent, right? This is not something that you want to work with indoors in an enclosed environment. So please do this safely, uh, do it responsibly. One caution is not to expose these resins directly to UV light, especially the anion resins. Certain resins are actually very sensitive and they will actually degrade and get damaged in UV light. So if you do it outside, do it where you have a roof or some shade where it's not directly exposed to the sun. Okay, so now we just simply close this up, lock it down, make sure that's tight. Before you lock it down, make sure you tighten it up and then lock it down. Same thing with the other side. Well, actually first you tighten it first on both sides and then you lock it down. And now you know it's safe. And then you can plug it in and then turn it on. So we're going to turn it on. We're just going to run it to the max setting and let it do its thing. Okay, now that we have let this run, I would also be careful not to let it run too much. It does actually get hot, so as we see, it does get a little warm, so don't let it too much. You'll actually probably see it steam when I open it up. Loosen this up a little bit so it can open. Just shake the lid so it gets all the top out. And there we go. Now we have our powder resin. So now we're going to mix it together. What I recommend doing is simply scooping it out to the cup. Very easy. You can do it right. It is actually preferable to do it right after you mix it because the humidity is still there. If you don't plan to use it immediately, what I actually recommend doing is leaving the cap on because again, it's hard to see on camera, but it's actually it is steaming a little bit. So, but we fill it up. So however much, it doesn't have to be perfect. Uh, yes, you can optimize the ratios, but just for demonstration purposes and to make the point of how easy this recipe is, we're not going to weigh anything. We're not going to do anything exact. We're just going to eyeball it and see how it goes. So another thing I'm going to do is actually mix in. So whatever volume you did of the resin, I recommend mixing in about a sixth or a third with PVC. Sorry, with the fiberglass. So maybe a sixth. It's all eyeballed. I know this might seem weird, but it's just eyeball it. You don't have to be perfect. So about a sixth or so, maybe a little more, with fiberglass. Then we're gonna add the same volume of the PVC cement to the same volume of resin that we have. So again, I'm just gonna eyeball this, but we have approximately the same amount. And now we simply use a spoon to mix it together. So it's kind of hard to do with one hand. Put the microphone down and mix it up. Okay, now that we have this all mixed up, we can actually now apply it. So like I said, I use a polypropylene sheet, but you can use a fiberglass mesh or some sort or woven sheet. Nighthawk actually has a video where a live podcast where she actually applies onto a fiberglass woven sheet, but you can just use a regular old polypropylene sheet and simply pour it out. Simple as that. And next, this is again hard to do by hand, but what I'm going to do is shake the sheet so we get an even surface throughout. Okay, so now that we have applied it out, we're just gonna sit and let it dry. Again, you do not want to let it fully dry. You want it to dry out where you can actually then start to peel it. So we'll just come back a couple hours and see how it goes. So I messed up and I recorded a video without turning on my mic. But anyways, point is, you can start to notice when it's ready, when the edges start to peel up. And what you do is, as you see in the video, I simply peel it off. It took me about 6 hours in that. Honestly, you could wait probably an extra hour or two, but the bottom sides ends up being a little sticky, as you see. That's why it's important to wear gloves. But point is, at this point, it's actually ready. So you can use a knife like this. In this case, I use a knife, and you make sure to use a cutting board. Though I prefer scissors, and make sure they're really good heavy-duty scissors that's capable of cutting the fiberglass strands. But yeah, now you have a cation exchange membrane. Because this is from PVC, you could use PVC glue to glue it to your electrolysis cells. In this case, I'm actually going to do a test demonstration using a hot glue gun, this little cup, and cutting out this membrane, and also some salt water and electrolysis, and showing you the pH differential. So let's get started. Okay, so we have our cup assembled now, and we're gonna use some salt water as a test. Be careful doing this. Do not actually do this indoors, because the chlorine will it will produce chlorine, and that will rust up your equipment, and that is not a good thing. But as a test, just to show you that this is regular salt water, say it is a neutral pH, normal pH. But what we're going to do first test is fill up just one side to show you that it is non-permeable. Pretty much water will not be allowed to go through, as you see. Again, we're doing a very basic test. Pretty much will electrolyze salt water, show you that an acid and base is being formed. But I have other videos that actually go further into deeper dive regarding this in the process. Additionally, you have to polarize the membrane. So pretty much you run a larger than normal voltage through it to pretty much activate it and kickstart the process, if that makes sense. So it heavily depends on which chemicals you're using, which solutions you're using, so on and so forth, so on and so forth. So definitely, it depends on a case basis. But in this case, you'll see me. This I'm just using a graphite positive electrode and a stainless steel negative electrode. Okay, so like I said, you can see it starting to run the reaction, and we're actually gonna change the. How do we do this? There we go. So we're actually gonna increase the voltage temporarily. So we're gonna run it at that, and then we're gonna set the. There we go. It's at 0.2 amps. So you want to. What I recommend doing is setting the power supply at a fixed amperage. Not too crazy high of a voltage. Because in case you have a bad connection or whatever over time. But as you see, the voltage is drastically dropping down, and that is the membrane polarizing. We see the bubbling going off the electrodes, and actually I can in fact smell it. But there we go. We have an alkaline. I'll put it right here, and then we'll have the acidic being produced here. So it's mostly chlorine gas being produced. That's why the solution itself is not going to be acidic. It's going to need some time for the chlorine actually to, technically speaking, you need a UV lamp for the chlorine and hydrogen to react and then, form hydrochloric acid. But yeah, you get the point. But point is, what's happening is sodium ions are passing through on this side, and actually the chlorine ions are not allowed to pass through. So they mostly either get bubbled here or they get reduced over here. We have it working. The voltage is continuing to drop. So it's going to take maybe like 10-20 minutes for it to fully polarize and turn into normal voltage. Like I said, I have other videos that show it running longer, but I hope this helps somebody with understanding these electrolysis cells and how to build one yourself in. how easy it is to make these ion exchange membranes. There's so many applications to them. Like I said, I'm gonna make dedicated videos. You can make sulfuric acid. You can make calcium hydroxides. You can make sodium hydroxides, right, for the geopolymers, various acids, so on and so forth, so on and so forth. So many things. For example, you can make sulfuric acid from just regular old gypsum. So I'll make videos dedicating all this, but I'm actually going to turn this off because I don't want to produce too much chlorine in my lab. But yeah, hope you like this video. Hope it helps you. And again, please, if you really want to help this technology, the best thing you could do is share the video. Otherwise, I have a shop, a store, a website on my store. It's rowow.net, and you can visit my website and actually buy these membranes. There's a liability disclaimer that you're not going to use this without the right safety, without the right laboratory. This is just for research and development. This should not be used for any commercial application. This is not a consumer item. This is purely for research and development. Please understand that very well. Watch my safety video first. It's actually required in the liability disclaimer for you to watch the safety video in order to purchase these membranes or any other components. So otherwise, again, please, if you want to help out, the best way is just to share it. I also have a GoFundMe where we're trying to raise the vacuum filtration drum, so hopefully we'll be able to buy that and scale up our salt electromining technology. But anyways, thank you for watching, and please stay subscribed. I'll keep uploading more videos.